So before we move any further, I want to look at the Algebra 1 formula sheet that you're going to see on the Georgia Milestones EOC. So if you look over here, we talk about, we have over here your algebra formulas. Now on this side, we start to talk about your statistics formulas. So let's go through these just to make sure that you understand everything that goes on with them. So average rate of change, that's left over from algebra. Here are the statistics formulas, okay? So the mean, remember, is the average. That's where you add up all the numbers and you divide by the number of numbers. That's what this is. So remember when we talked about sequences way back, we said the subscript represented the position. So I want you to think of this as the first term plus the second plus the third plus the fourth number plus the fifth number plus the sixth number plus the 10th number, if there are 10 numbers, and then we divide by 10. So X bar represents the mean. So you're going to add up all of your numbers and divide by the number of numbers. Interquartile range we'll talk about later, but today we're going to talk about the mean absolute deviation. It is the sum of the distances between each data value and the mean divided by the number of data values. That's what this means. Mean. Okay. X bar, remember, is the mean. So this says we take each number minus the mean. We'll find its absolute values. Its absolute value. So we'll do that for all of the numbers. This is the Greek letter sigma, which represents sum in mathematics. So once you find each number from the mean, or each distance from the mean, and find their absolute values, you'll add up all the absolute values and then divide by the number of numbers. Okay, so the mean is the distance of all the numbers from some central value. No, I said that wrong. The mean would be the center of all the numbers. The mean absolute deviation is the average distance from the mean. Okay, so that's what you have in your formula sheet related to statistics, mean and mean absolute deviation. So let's talk about mean absolute deviation. Please remember that the mean of a data set represents what each value would be if you evenly distributed every number, okay? The objective here is to find the mean absolute deviation. The mean absolute deviation, it is the average or the mean of the absolute distance of each value, okay? When we mean absolute, we're talking about the positive value. Whether you're 5 above or 5 below, you're still 5 away. So keep that in mind. These are the steps to find the absolute deviation. You'll put the data in order. You really don't have to, but keep in mind when I give you an assignment, I'm going to ask for the mean, the median, the mode, the range, and the mean absolute deviation. So you've got to put the data in order for the median. So go ahead and just do it now. You'll find the mean of your data set. You'll make a table that shows each value and how far away it is from the mean. You'll find the sum of all your deviations and you'll divide by that number of numbers. So mean, it's the average of the positive distances from the mean, okay? The positive distances from the mean. And by the way, this worksheet comes from this lady. Don't be discouraged. As I told you before, this does come from her 6th grade math, but that's because this used to be a 6th grade standard. It was in 9th grade 10 years ago. They moved it to 6th grade because it's computation, but they moved it back to 9th grade because they expect you to be able to do the computation and do some interpretation, which is what we'll be doing. So let's say I asked 12 students how long they can hold their breath underwater, and this is what we find out. So we want to find the mean absolute deviation, okay? So the first thing that's done here is they put all of the data in order. So those 12 numbers that were up there, we're going to put those in order. And the first thing we're going to do is we're going to find the mean. Remember, the mean is X bar. So when we do that, we find the sum of the numbers is 324, and then we divide by 12 because there are 12 numbers. And you're thinking, why are you telling me this? Well, remember from the formula sheet, we're adding all these values. We get to the 11th number and the 12th number. Since there are 12 numbers, we divide by 12. So 27 is our mean. Okay, so that takes care of that part. Then we have to make a table that shows each value and its deviation from the mean. So 3 is 24 units below. We just say it's 24 units away. Remember, we don't care above or below. We just want to know how far away. 19 is 8 units away from the mean. 20 is 7 units below. 25 is 2 units away. 26 is 1 away. 28 is 1 away. 1 above, 1 below, 1 above, it doesn't matter. They're still each 1 unit away, and that's what we're measuring. 29 is 2 units away. 30 is 3 units away. 31 is 4 units away. 35 is 8 units away. 36 is 9 units away. 42 is 15 units away. So we're going to take all of these distances from the mean. We're going to add them up. We find that when you add all those distances, you get 84. And then we're going to take the sum of 84 and divide it by the 12 numbers that there are, because remember, we're finding a mean. 84 divided by 12 is 7. So the mean absolute deviation, which I'm going to call the MAD for this problem, is 7. Okay, what does that mean? Well, loosely, what it means is that you are, the average distance from the mean is 7 units. Okay. So here's what they do. They check that the MAD should be between the highest and lowest deviations. Okay, well, look here. My lowest deviation was 1. My greatest deviation was 24. So the mean should be within there. Okay, and it was. 84 divided by 12 was 7. So what is the mean absolute deviation really? I want you to think that the average distance from the mean, I should say the average distance of all numbers from the mean is 7. Okay, that's really what we're looking for. Okay, so we're going to do a few examples, and you're going to notice some things, and I really hope you do, and then we're going to talk about some things with it. Okay, so find the mean absolute deviation of each data set, then explain what it means. Okay, so here's what I do. I'm going to follow their steps, and I'm going to put the data set in order. I'm going to leave the steps. Remember these steps right here? I'm going to leave it right here where I can follow them. It says put the data set in order. Now, most of you like to say, all right, I'm going to put a 1 and then you color it out. No, 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 because if we mess up, we want to make sure we can account for each number. So 1 is my first number. Then I see a 2. Then I see a 3, a 4, a 5, another 5, another 5, a 6, a 9, and let's get our last number, a 10 in here. Okay, so to find the mean, first of all, I'm going to look at all of these, and I'm going to add these up. And because I'm going to have to go fancy today, and this is the big brother of the TI 30XS that we use in class. This is the TI 84 plus CE. Okay, so I'm going to add up my numbers. And I get 50. Okay, so when I add these up, I get 50. Okay, and so to find my mean is 50 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, divided by 10. So my mean here is 5. Okay, so I found the mean of my data set. Going to make a table that shows each value and how far it is from the mean. Okay, So I need to take 1 minus 5. That's -4. But all I really care about is its absolute value. So I guess we'll look at it this way. Okay. So let's look at how far away 2 is away. I'll do a few of these. Absolute value of -3 is 3. 3 minus 5 is -2. Its absolute value is 2. 4 minus 5 has a distance of 1. Here we go. 5 minus 5 is 0. So 5 is the mean, so it's 0 units away from the mean. 6 minus 5 is 1. 9 minus 5 is 1. 10 minus 5 is 5. Okay, so now we have to find another mean. So let's do that. All right, so I'm going to take 4 plus 3 plus 2 plus 1. I don't need to put these zeros in, but I am just because I'm ridiculous. And I see that there are 17 numbers. Did I forget something? 2, 1, 1, 1, 5. Okay. Oh my goodness, that's a 4. Okay, so these numbers add to 20. Okay, so for this problem, my mean absolute deviation is 20 divided by 10, which is 2. Okay, so the average distance from the mean for this problem, for this set of numbers, is 2. That's what it means. Okay. All right, let's look at our next set of numbers. And I think I want to make a few adjustments here, and I should have paid attention or planned better. Okay, so let's look at our number. I'm actually going to use the formula here. Let's look at each value minus the mean. Okay, so my first number is 1. 2, 3. Okay, there's a 4. Any more 4s? And there's a 5. There's 1, 2, 3, 4. 5. Okay, there are 5 5s. And I've got 2 6s. And then I have an 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's try those. 1 plus 4 plus 1, 2, 3, 4, 5. We get 50. Oh, we get 50. And 50 divided by 10 is 5. So my mean, again, is 5. Okay, so now I'm going to take the absolute value of 1 minus 5, and I get 4. The absolute value of 4 minus 5 is 1. The absolute value of 5 minus 5, 5 minus 5. So 5 is 0 units away from the mean because 5 is the mean. 6 minus 5. 6 is 1 unit away. 8 is 3 units away. Okay, so when we add these up, 4 plus 1 is 5, 6, 7, 8, 9, 10. So when we add these, we get 10. And therefore, in this problem, my mean absolute deviation is 10 divided by 10, which is 1. Okay, so what that means is these numbers, the average distance of these numbers from the mean of 5 is 1. Okay, so I have a mean absolute deviation of 2. I have a mean absolute deviation of 1. So we'll think about that for a second. And now let's look at our final set. We're going to look at x. We're going to look at the absolute value of each number minus the mean. Actually, doing this so backwards. What's wrong with me today? So it's each number minus the mean. Not that it matters, because once you take the absolute value, you get the same answer anyway, but I want to follow the formula and be consistent for you. All right, so let's look at this one. We have, okay, I've got a 0 in this one, and a 0 and a 0. So there are 3 zeros. 1, there's a 2 and a 3, 4, 5, 6, 7. There's an 8. There's a 9, 3 9s. And then finally, there's a 10. All right, so when we add these, 0 plus 0, we'll stay consistent. We really don't need to type in the 0 there because you know when you add 0 to anything, it's the same value. Okay, so this sum is 50. So when I find my x bar, again, 50 divided by 10 is 5. So we know our mean is 5. Now we need to take each value minus the mean. 0 minus 5. So 0 is 5 units away. It doesn't matter whether it's above 5 or below 5. The distance is 5, even though we know it's below. 2 is 3 units away. 3 is 2 units away. 8 is 3 units away. 9 is 4 units away. And that happens 3 times here. And then 10 is 5 units away. All right, let's add these. Yeah, I noticed with this lighting, it turns everything yellow, and I apologize for that. I'll plan better the next time. So let's find our mean here. 5 plus 5 plus 5 plus 3 plus 2 plus 3. Okay, so that adds up to 40. So the mean absolute deviation for this one is 40 divided by 10, which is 4. Okay, so here's the crazy thing. All of these numbers, all of these sets, these 3 sets of data had a mean absolute had a mean of 5. The mean for each of these was 5. But I had several different mean absolute deviations. And so the average distance of this set of numbers was 2. The average distance from the mean of this set of numbers was 1. The average distance for this set of numbers from the mean was 4. And so we're probably wondering, how in the world does that work? Okay, how mean absolute deviation is a deviation. It describes the spread of the numbers. So maybe to look at the spread of the numbers, we should consider a line plot or a dot plot. I think I'm going to use dots today just because my x's aren't always uniform. So let's look at example 1, where our mean absolute deviation is 2. In example 2, we'll have MAD of 1, and in our third example, the MAD was 4. Okay, so let's look at our numbers. So I've got a 6, which is here, and a 9, and then a 2, and then a 10, and then a 4, and then a 5, and then another 5, and another 5, a 1, and a 3. Okay. So there's nothing really remarkable about this. I noticed that my data ranges from 1 to 10, and I see that I have a couple of numbers. A couple of entries are 5, the mean. Okay, so they're sort of spread out a little bit. Okay, let's look at data set 2. So I've got 6, 5, 6, 4, 5, 1, 5 again, 8, 5, and 5. Okay, what do you notice here? Well, here the data only ranges from 1 to 8. So the range here is 7, where here the range was 9. So it looks like the data is sort of a little closer. But I also notice that I've got several of the elements in this set that are 5. So it looks like the numbers are closer together. So these numbers are closer. And notice the mean absolute deviation is smaller. All right, so let's look at this last one. We've got a 9, a 9, a 0, an 8, a 9, a 3, a 2, a 10, a 0, and a 0. That's interesting. It seems to fill in the gaps that are left here. So this data has a range of 10 minus 0, has a range of 10. So I've got data outside of my mean. My mean is 5, remember? So you would think, oh goodness, you know, my mean is here. And there is nothing, even the closest to it is 2 units away or 3 units away. Notice the mean here was 5. The mean here was also 5. So it looks like the more centered or central your data is, the smaller your mean absolute deviation. These numbers are farther away from each other. And notice we have a larger mean absolute deviation. So it looks like if your numbers are closer together, your mean absolute deviation is smaller. If your numbers are really not just spread out, because look at this. This is spread out, this is spread out. But notice, at least we have some numbers that are close to the mean here. Here, man, they're at the outer edges, okay? So I guess what I want you to take away from this is the closer the data, the smaller the MAD. The more spread out and away from the center of the data, the larger the MAD, okay? So to summarize, we're going to find the mean of our set of numbers. We find the distance that each number is from the mean. We find the mean of the distances, and that's how we'll find the mean absolute deviation. And then when we interpret the mean absolute deviation, we're just looking for, I guess you could say loosely, the average distance from the mean. So here we calculate and we interpret, and you'll be all right.